we're going to go over the concept of an... there was a word we learned last day, and it starts with an I, and I'm wondering if you guys can remember what that word is that started with the letter I. And feel free to go get yourself some paper. I think it's hiding behind this thing here. Do you need some? Isotope, yes. Please tell your neighbor what is an isotope. What is an isotope? Anyone want to tell me? Yes.
That's an atom with 4 neutrons.
Yeah, it's an atom. They are atoms. Actually, I should put isotopes because you usually don't talk about just a single isotope. Isotopes are atoms of the same element that have different numbers of what's different about them? Tell your partner, what is different about different isotopes? There's 2 things. Yeah, there was, 81 and 82 were just reading. Yeah. Anyone? Yes. Yeah, they have different numbers of neutrons. And because they have different numbers of neutrons, that gives them different masses. And let's remind ourselves, how do we calculate the mass of an atom? How do you calculate the mass of an atom? Yes. Yeah. So the mass of an atom is equal to the protons plus the neutrons. What do we call the mass of an atom? Mass of an atom is called the mass number. And we can abbreviate that either as mass NO. Are you guys familiar with that for number? Okay, so you'll sometimes see it like that, or sometimes you'll see it like this, mass number. Are you okay with me just putting P for protons and N for neutrons? Okay, all right. I get a little, sometimes because I teach Chem 11 and we've done protons and neutrons for so long by then, I forget that I maybe should write out the whole word for you, but I think you guys are good. Okay, so that is our mass number. And when we write the name of an isotope, how do we show the mass number? This is when we're writing the name. So let's say, for example, we wanted to do, I don't know, chlorine. So say we wanted chlorine, which has an atomic number equals 17. And the mass number is equal to 35. Yeah. Chlorine dash 35, yes. How many neutrons? How do we find (35 minus 17? Okay, so we take the mass number minus the protons. So that's 35 minus 17, which is 30 minus 10 is 20, minus 5 is 15, minus 2 is 13. No, I've done my math wrong. I'm going to do it on a calculator because I'm not smart enough.
18.
18. Like, what is wrong with me? Oh my gosh. 18. So we have 18 neutrons. Okay. Now, by the way, if anyone at the end of this would like a printout of these notes, I can make that for you. Okay, so if you're like, this is too much for me to copy down, I can make a printout for you. All right. How would we show the symbol for this isotope? Yes. Okay, so it's actually Cl, but that's okay. Cl. 35, where? On top here? On the left side, very good. Okay, so 35 on the top. Remember, big number goes on the top. And what would go on the bottom? 17. So that is our mass number. And that is our atomic number. How many electrons in this chlorine atom? Yes. 17. Because we have 17 protons, which means we have 17 positives, and atoms are neutral. Therefore, we need 17 negative, which gives us 17 electrons. Excellent. So that's like a little review of what we did yesterday. And who would like a printout of that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'll make a class set. Okay, let's just go File, Print. And let's go to 338. And let's make 26. Print. Okay. Okay, and now what we're going to do is we are going to move on to page 87. Okay? Page 87.
Let's talk about the difference
Page 87.
between mass number and atomic mass.
That's annoying, isn't it? We have two things called mass number and atomic mass. They sound the same. They are not the same. And many students confuse them, and I don't want you to confuse them, okay?
These things sound very similar, but they're actually very different. Just so you know, atomic mass can go by other names. Sometimes it's called average atomic mass, or relative atomic mass, or even atomic weight.
And it would actually be really nice if all the time we referred to it as the average atomic mass, because that kind of gives you the best idea of what it is. Okay?
Maybe your teacher calls it one of these. For our purposes, in this video, we're just going to call it atomic mass. So, we're talking about the difference between these two things. Let's start by talking about mass number. So up here, I've got two atoms. They've got protons and neutrons in their nucleus, and I'm particularly concerned with the number of protons and neutrons that there are. So this atom over here has 5 protons. The protons are these red circles. We can count them up. 5 protons, and the neutrons are these blue circles. We could count them up. We got 5 of those. This atom over here also has 5 protons, but it's got 6 neutrons. So, mass number is the number of protons plus the number of neutrons. So this atom here has a mass number of 10. 5 plus 5. And this atom over here has a mass number of 11. 5 plus 6. Mass number tells us how many protons and neutrons are in the nucleus of an atom. But it's also important because it gives us an idea of how much the atom weighs. You might remember, we've said before, that 1 proton or 1 neutron weighs about 1 AMU, 1 atomic mass unit. So, if you have a mass number of 10, 5 protons and 5 neutrons, your atom is going to weigh about 10 AMU. If you have a mass number of 11, that tells you that the atom here weighs about 11 AMU.
And we're going to pause there for a moment, make sure that we've filled in everything, and I'm going to ask you a couple of questions. So let's bop over here. Our mass number for atom A is, what's our mass number? 10. 5 plus 5 gives us 10. What's our mass number for our second atom? 11. 5 plus 6 gives us 11. And how much does 1 proton weigh? 1 proton or 1 neutron weighs 1 AMU. All I need you to know about the mass of an electron is that it is much, much smaller. Okay, I don't need you to memorize 0.000549. You don't need to know that. You just need to know that the electron's mass is a lot smaller. All right, so if we have a mass number of 10, that means it weighs 10 AMU. And if we have a mass number of 11, that means it weighs 11 AMU. So mass number is the protons plus the neutrons. And now I would like you, make sure you have your periodic table out. So I should see a yellow page out in front of you. If you are missing it, let me know. I can get you an extra one. Anyone need an extra? We're good? You guys need an extra? Then you don't have to be waiting for work. Okay. All right, so we've got, what atom is this? What element do we have here? You can use your periodic table, figure out what element this is. We have two isotopes. This is boron. How did you know that it is boron? Because the atomic number is 5. Thank you very much. Okay. Excellent. All right. Now, there are definitions here. The mass number, and this is not from Tyler, this is just because we want to have this here. The mass number is the mass of a specific isotope. So you're either looking at the mass of the atom on the left, which is 10, or you're looking at the mass of the atom on the right, which is 11. Okay, so it will always be a whole number. Yes? So mass number is always a whole number. No decimals. And it is the one, you're going to be filling in a bunch of charts. This is the one that's going to go in the charts. Okay, this is the one you can calculate. You can calculate this one. Here's another thing. It is not on the periodic table. The reason it's not on the periodic table is that sometimes an element might have up to 8 isotopes. Each one would have a different what? Each isotope would have a different mass, and everyone would have a different mass number. Can you imagine trying to cram 8 different numbers into that little square on the periodic table? Wouldn't that be crazy? Right? The square is about this big, right? We've got, say, oh, I don't know, bromine. Or actually, we had calcium last day, and we had calcium, and it's atomic number 20. And then imagine if I had to write 42, 43, 45, 48, 50. Can you imagine if I had to write on all of those for the mass number? That would be crazy. It would just get really cluttered. It would be hard to read. And also, it's not very useful. Okay? So we don't write the mass number on the periodic table. So if you're asked to find mass number, it is not on the periodic table. Not. All right. Atomic mass, on the other hand, is the average mass of all the isotopes. So if we look on our periodic table for, say, bromine, or actually, let's say chlorine. Where's chlorine? Chlorine's a good one. Here's chlorine. That is its atomic number. And that right there is the average atomic mass. Would it be possible for 35.5 to be the mass number? No, because we cannot have half of a proton or half of a neutron, okay? So on your periodic table, you might want to add the word average, where it says atomic mass. And you could also add in that this is not the mass number. Sometimes you'll be tempted to think it is. Some of them look nice. 52.0. Oh, that looks like a good one, but it's not. It's still an average. And in fact, if you had a periodic table with more decimal places, you would see that it's not actually 0.0. It's probably like 0.0137, blah, blah, blah. Yeah? Okay, let's go back to here. And we are now going to flip to page 88.
These atoms both have electrons, but electrons are so tiny and they have such a small amount of mass that we don't even worry about the mass of electrons when we're weighing up stuff to determine how much the larger atom would weigh. So 10 AMU, 11 AMU. So that's mass number. Protons plus neutrons, and it gives you an idea of how much the atom weighs in AMU. Now, let's talk about atomic mass. You might notice that both of these atoms have the same number of protons in their nucleus. 5 protons here and 5 protons here. This means that they are the same element, right? Because the number of protons an atom has determines what kind of an element it is. So, we can look on the periodic table to find out what element these atoms are. And it turns out that they're boron, because boron up here has an atomic number of 5. 5 protons in your boron. So, both of these atoms are different versions of boron. They're different isotopes. An isotope is a word that just means a different version of an atom that has the same number of protons, but a different number of neutrons. We can give distinct names to these two isotopes or versions of boron. This atom over here.
So what would we call the boron on the left? We would call it boron 10. And what would we call the boron on the right? Boron 11.
Here is an example of boron 10 because it has a mass number of 10, 5 plus 5. And this atom here is an isotope of boron called boron 11. 5 plus 6 has a mass number of 11. So, there are billions and trillions and gazillions of boron atoms in the world. If we could pick one up at random, it could be either one of these two types. Okay, it could be a boron 10 atom with 5 protons and 5 neutrons, or it might be a boron 11 atom with 5 protons and 6 neutrons. So boron comes in these two versions. Now the thing is, there is not an equal number of boron 10 atoms and boron 11 atoms. In fact, if we...
So in other words, it's not 50-50. Okay? Now actually what I'd like you to do is I would like you to look on your periodic table at boron. Where is it? There it is. All right, so here's boron. It has an average atomic... What is the average atomic mass of boron? 10.8. Can you guess which boron is more common in nature? Is it boron 10 or is it boron 11? 11. Why is it 11? Yeah. Yeah, the average is closer to 11. So if you have more atoms weighing 11, the average will be closer to 11. All right.
We pulled 50 boron atoms at random and represented them here. We'd see that the majority of the boron atoms are boron 11, which I'm indicating with little orange circles here. Okay, most of them are boron 11, and only a small minority of them are boron 10 atoms. We can look at this on a pie chart just to get this point home, and you can see that the vast majority of them are boron 11, with a smaller amount that's boron 10. If you crank through the math here, you'll find out that about 20% of the boron atoms in the world are boron 10, whereas 80% of them are boron 11. This leads us to the idea of atomic mass. Now, atomic mass asks what is the average mass of a boron atom. All right? We've got these two types of boron atoms. We've got boron 10 that weighs 10 AMU. That's what its mass is. And we've got boron 11, which weighs 11 AMU. That's what its mass is. But here's the thing. There's only 20% of this guy and 80% of this guy. So now we're asking, got these two types of boron, what is the average mass of a boron atom? Now, you might think average and say that's pretty easy. I know how to take an average. This guy weighs 10, this guy weighs 11. So why don't I just add the two of them up, 10 plus 11, and divide by 2? And then I'll get 10.5, right? That's how I take an average.
Except that's not how you take an average when you don't have 50. Yeah? You have to have half and half to do that.
Okay? No, it's wrong. That is one way that you can take an average, but it won't work here. And the reason why is because this type of thing, added up and divided by 2, assumes that we have the same amount of both of these. If we had 50% boron 10 and 50% boron 11, then we could just add them up and divide by 2. But we can't do that because we have different amounts of these two types of atom. Okay? And we have to come up with a mathematical equation that's more complex than this to take into account the different amounts that we have of these two atoms. Here's how we do it. We take the fact that there are 20% boron 10 atoms and that they weigh 10 AMU each, so 20% times 10 AMU. And then we add that to 80%, which is over here, times 11 AMU. And we do that math, we have to convert the percentages into decimals, but when we crank through this, we end up with 10.8 AMU. And this tells us what the average weight of a boron atom is, taking into mind that only 20% of the boron atoms out there are boron 10, and 80% of the boron atoms out there are boron 11.
Okay, so we're going to leave it at that. Let us just make sure that we got everything on that page. So we have, where to go? There it is. All right, so this is boron 10. And this is boron 11. And if we wanted to write the symbols for those, if we wrote the B, where would we write the 10? The 10 would go at the top. And boron 11, the 11 would go at the top. What number would go at the bottom for these B's? 5, because there are 5 protons in each of them. Okay, this one here, 20%. This one here, 80%. Now, if you're like, why is there this weird number A for mass number? It's because the symbol for mass number actually is the letter A. You are not expected to know that for grade 9. Like if you're like, that just sounds too confusing because it's not atomic number. Atomic number is actually represented by the letter Z. And then A represents the mass number. But I'm just telling you because Tyler has it. Okay, so our mass number here is 10. Our mass number here is 11. So boron 10 weighs 10 what's? AMU. What does AMU stand for? Atomic mass units. And boron 11 weighs 11 AMU. Here's our little representation. 20%, boron 10, 80%, boron 11. Average atomic mass, we cannot just take 10 and 11 and divide by 2 and get 10.5. That's a big old nope, because it's wrong. So we would take 20% times 10 AMU and 80% times 11 AMU. And if you're interested in the math behind that, you would have to take 0.2 times 10 and then add it to 0.8 times 11. You make the percents into decimals and then you would add them and you will get 10.8. You do not need to be able to do this math, but if you are interested, I have a calculating average atomic mass extra enriched thing. I'm just going to send this sheet of paper around. If you want it, put your name on here and I'll have it for you for tomorrow. Okay, so if you're interested in the enriched calculating average atomic mass, put your name on that sheet of paper. Pass it around. If you don't want it, don't put your name down. But if you're interested in this kind of thing, then you can. And for those of you who were calculating your grades, and you're like, hang on, these don't average out to what my average is, that's because your grades are also weighted. Quizzes are 10%, so you average your quizzes and you take 0.1 of that. You average your tests and you take 0.8 of that. You average your labs and you take 0.1 of that. So it's also very similar. All right, so you guys can do page 89 to 93. Okay.